I'm GUILLAUME OZOUF from Kilowatt. I'm going to show you the general concept of the Aqueous organic electrode batteries that we have developed in Kilowatt. Before that, just a few words of the concept of the context, and in order to show you for which application we want to address our technology. So, as almost everybody here may know, renewable energy are intermittent. So that means the production do not match with the needs. So the idea is to store the energy when the price is high and restitute the energy. When the price is low and restitute the energy when the price is high. So, and if we consider the evolution of the French spot energy prices, you can see that the energy price increased by a factor of 10 in 7 years. So regarding all of this data, storage energy technology become more and more attractive and more competitive. But here, this is the expecting evolution of the new installed capacity per year according also to the storage discharge duration. So, in the next couple of years, they will have much more new installed capacity, especially for the long discharge duration. And this is exactly in this application. In this application, we want to address our technology. If you have a look on the specific characteristic in terms of performance of our Redox batteries, you can see that this performance matches perfectly with many applications, and especially micro and smart grids and renewable energy integration. So, seems nice, but how does it work? Basically, we have two blocks. One for the power and one for the energy. Okay. The energy blocks is composed of electrolytes where we store energy. Electrolytes, in fact, basically, it's our electrochemical active molecule dissolved in water. So these active molecules are recyclable, and about the power blocks, it's composed of stacks which is basically the energy converters, and these two blocks are linked by a system of pump. So this system allows to dissociate the energy and the power. In fact, if you want more power, you just need to increase the number of stacks. And if you want more energy, you just need to increase the volume of stacks. So this allows us to be fully scalable to match with all customer requirements. So here you have some example for a small scale system of several kilowatts and a large scale system of some megawatt. So, as I said, we have two electrodes. One is for the positive side of the batteries, called pozolite, and the other one is for the negative side of the battery, it's called negolite. So in the positive side, the electrolytes are composed of ferrocyanide, potassium ferrocyanide, which is a food additive, a very cheap food additive. You can find it in salt and wine. And in the negative side, we use anthraquinone can molecule. So basically, such molecules are typically used in dye industry. However, in Kilowatt, in order to improve performances, we have developed our own chemistry and our own active molecule for the negolite side. So this is our proprietary molecule. So here you have well, yes, a picture of one of our modules. You can see the two tanks, the stacks, and the system of pump linking stack and electrolytes. So here are some main features of our technology. So, and some main advantage we can say. So we have a low OpEx with a minimal maintenance and a long life. We expect 20 years or 20,000 cycles. We have also a really safe and reliable system with absolutely no fire, no explosion possibilities, and no thermal runaway issue. And the operating temperature is room temperature, let's say between 5 and 40 degrees. We also have a low capex. First, because of our chemistry, we control the synthesis and we have chip synthesis. We have also a robust and a simple design, for instance. As I said before, our system is scalable, easily scalable. We can dissociate the power and the energy, so we can be scalable for all application, all kind of application. And finally, our technology is also environmentally friendly with recyclable electrolytes, absolutely no regulators or rare earths, and almost all of our materials are recyclable. So in Kilowatt, we have also made huge effort on the eco-compatibility of our technology. So from the beginning of life to the end of life. Beginning of life starts with the synthesis of our active molecule. So we develop a synthesis pathway with bio-based solvent and water. We recover all, as much as possible, the unreacted main reagent, and our synthesis can be implemented anywhere. At the end of life, we have also worked on the recyclability of our both electrolytes. So here you can see an example of what we can obtain when we cycle with new electrolytes and we recycle one. So basically no major difference in terms of performances. So here, this is our phase approach to scale markets and application. So at the beginning, we were more in a project demonstrator with some partners. And now we have started the commercial product. So in fact, there is a nice synergy into our market because renewable energy integration and micro and smart grid for decentralized energy solution are strongly linked. So yeah. So as I said before, so allows to address our technology for many applications, grid services, beyond the matter and off-grid. Okay, here some main feature, some main feature, well, yeah, of the history of Kilowatt. So Kilowatt was founded in 2014, so it's quite recent. In 2016, we have developed the first world prototype of Aqueous organic redox flow batteries of 5 kilowatts. So in 2018, we have won the World Innovative Competition. That was a good achievement, in fact. In 2019, we have connected the first demonstrator to an external building. And in 2020, we have also signed our first commercial contract for different systems. For instance, one of 33 kilowatt, 100 kilowatt hours. it's the biggest one right now. And of course, we expect to continue our commercialization phases. Yeah.